this thing. K11, K12, small case, K21, K22, right? And this from second filter, second kernel you can take, filter or kernel. And again these are suffix 1 only, like will be 1 only, because this is for the first input channel, this is for second input channel, this is the third input channel. And you can also give one square bracket notation telling this is a second filter for all those elements, and telling this as first for the first filter they are denoting. So what I'm saying is these are the first filters, so we can just give suffix 1 also over here. So it will be K11 dash, here 1, and this will be K11, it's not dash actually, yeah, it's 1 actually, for it's giving for first channel. Here this 2 means second channel, 3 means third channel, and 2 here 2 we have to give, that means second filter. So here 2, here it will be 1 for everything, 2 over here. So what I'm saying is, like, we can't perform like that because this is matrix of matrices. So element wise we can perform as I've shown previously. Element wise we can perform over here, that's no problem at all. As you've seen, all those derivatives we are getting wherever x1 k11 is there, so we will take the product of sum of products. So we can, wherever k11 is there, we can take sum of products and we will get the answer as I've shown. But here it is matrix of matrix, we can't generalize that like that, because k21 appears only in second equation. So as derivative of sum is equal to sum of derivative, so k21 is appear only second term only, because in it y2 only it appears. Y2 is nothing but capital Y2, it appears only in capital Y2 over here. Because if we want to expand this, for example y2 is equal to, it's nothing but x1 convoluted with k11 plus x2 is convoluted, where is the generalized result? Here, right? So if I want to perform y2 means it's adding bias 2 plus j runs from 1 to 3, right? So x1 y12. So here what happens, y2 is equal to k1, x1 convoluted with k11, x2 convoluted with k12 plus x3 convoluted with k13 plus adding bias 2 is nothing but this thing, whole matrix we get. And if you will find the derivative, as we have find over here, k12 appears only in the second equation, and here de by dy2 will come as it is, and dy2 by dk21 is nothing but dy2 derivative with k21. K21 is actually we have to perform y2 means it will be 2 1 actually, because we are with respect to second filter we are doing, so it's not 1 2. So we are using this filter, right? So this with this, this with this, this with this, so all this will be 2 2 and 2 3. So guys, in whole what I'm trying to say is y2 if you want to get, we need to perform x1 convoluted with k21, this with this, plus x2 convoluted with k22, this with this, like in broader sense, in higher level. Lower level means we need to perform all this this with small letters we need to do, this we need to, okay fine. But in a higher level we need to perform something like this, x3 convoluted with k23, this thing, this with this, and add bias b2, this. So if we are going to perform over here, as you can see, whole result, k21 appears only in the second equation, this thing, and d by dy2 will get as it is, and dy2 by dk21, k21 is over here, that is nothing but x1. So we are going to give x1 converted with dy2, so that is nothing but derivative of loss with respect to derivative of loss with respect to k21. So we can just generalize that by using IJs. So this is how we can just give a generalized equation using the capital variables, but using small variables this is fine, this one is fine definitely, because we have just shown you how with using just, if you have just one channel, that means one input image, one input for image, one channel, in that input image one channel is there, and one kernel, obviously depth will be same, and one bias matrix, you will get one output, right? So these are all matrices and vectors, matrices or vectors, 2D, 3D, 4D, or any n dimensions. So for those, these are same, like these are fine. For small variables, nothing, but low level for element wise this is fine. But if you want to generalize that using the capital variables, so matrix of matrices, vectors of vectors, n dimensional, one or n dimensional, for those we can define something like this, because k21 appears only in the second equation over here, like in y2 only it will appear. So we can just show that, because it will appear in y21 only, y2 only, actually it will appear in y2 only, 2-1, because in y3 we will get 3-1, because third filter will come over here, because this d is nothing but this thing, and here this n, j is from 1 to n, right? So j appears over here in the second case, second side it will, second suffix it will be there, and in x it will appear, because that is nothing but this depth, this depth is dimensions which we are calling, and this depth is what d refers to here, here, and this 1, 2, 3, these are nothing but number of channels or number of input image. This depth, dimension of input image. Similarly, we can show for bias, d by dy. If we have that, we need to find this thing, matrix of matrices, matrix of gradients, or suppose. So if you want to find this one first, it's nothing but y11 with respect to b11, d derivative of loss with respect to y11 multiplied by derivative of y11 with respect to b11. So matrix multiplication, we will get this for all the elements we need to find. Again, element wise we are doing, and these things will be 0, because dy12 with respect to b11 is 0. If I want to show that, so you can see derivative of y11, we don't have with respect to b11, right? y12, so derivative of y12, in 1, 2 we don't have b11 actually, because b11 is only impacted or only given to this, if you want to show, yeah, it will be given only over here only, b12 only here. So derivative of y12, that is nothing but this thing here b11 is not there at all. So if it is not there, means it's a constant, but it's not there, so that then derivative will be 0. Similarly for this also, in y21 and y22 also it will not be there b11, it will appear only in y11.